All right, everybody. Today we're going to be talking about a high accuracy workflow from end to end. So I'm here on site with my coworker Sal, who's another CSE, customer success engineer here at DroneDeploy. So we're going to walk you through the steps from all the way from planning all the way to uploading and viewing your data in DroneDeploy for a high accuracy mission. So some things we're going to be talking about today is some considerations when flying a high accuracy mission. So this site is 33 acres. We decided, because it's a relatively small site, that we're going to go with a single GCP workflow. If your consideration, even with small sites, is that you really need a high level of accuracy, you can do a full GCP map with all those GCPs encompassing that whole map. But for today's purposes, we're going to do a single GCP workflow where we can still get really good results for a 33 acre site like this. So some of the equipment we have on site today is an MLID RS2, and we're going to be collecting the actual coordinates of these ground control points and these checkpoints that we're going to be laying out today. And we also have a Mavic 3 Enterprise with RTK module, so we're going to be flying this site with RTK as well. Hence why we're able to do a single GCP workflow, is because we do have an RTK enabled drone that we're flying.
All right, so before we get started, we're going to talk about the topics that we're going to cover in this video. We're first going to talk about flight planning with the specific considerations concerning the Mavic 3 Enterprise with an RTK module. Then we're going to talk about GCP and checkpoint coordinate collection using an MLID, specifically the RS2. We're also going to talk about RTK versus PPK. Then we're going to go into flying the Mavic 3 Enterprise with RTK on this site. And we're going to look at uploading data, all your photos, and then tagging those GCPs and checkpoints through the DroneDeploy GCP tagging process. Then we're going to look at reviewing the data and doing some quality assurance on making sure that we got good, accurate data on this site.
All right, we're going to first talk about planning your flight before ever going out to the field for your high accuracy mission. So the first thing we're going to do is we're going to do a standard map here. Now, considering that we chose a single GCP workflow, it was based on a few factors. The first one being the number of acres here. This is a relatively small site, so we can get away with choosing a single GCP workflow here. And our accuracy threshold for this isn't super high, but you'll see we'll still be able to achieve sub-inch accuracy on this map, flying the Mavic 3 Enterprise with RTK and with that single GCP. And first, we're going to choose our altitude here. So for high accuracy missions, we really don't want to go above 200 feet. If we want to deliver very highly accurate maps, when we're talking about sub-inch, as you go higher, up to 300, 400 feet, you lose resolution in your photos, and thus you'll lose accuracy in your map. So if our goal is to deliver, inch to 2-inch or even sub-inch maps, we want to keep it 200 feet or below. If we want to really dial in our accuracy, we would turn this down maybe to 120 feet flying this drone and this equipment setup that we have. The second thing is that we just want to map terrain. We're not super interested in structures on this map. So since we're only mapping terrain, we want to leave Enhanced 3D off. This will increase our efficiency of capture. And one thing we're going to want to do just to understand our planning time and number of images is change this to a Mavic 3 Enterprise in the advanced settings button there. And you'll see this is an 8-minute flight with the Mavic 3 Enterprise with Enhanced 3D off. We can also understand our RTK coverage right here. So flying with RTK on this M3 enabled drone, we can see that we are in a covered area. Now, if we were in an area that lacked coverage with an amber or red icon here, we would want to fly this with a PPK workflow. But the big consideration with PPK here for post-process corrections is that we want this flight time to be about 10 minutes or more. So we could go into Enhanced 3D and we can turn on just Perimeter 3D here instead of Crosshatch to increase our flight time. Or if we didn't want Enhanced 3D on, we can adjust our flight speed here to be a little lower and to increase our time to capture just to ensure that we have convergence for that PPK flight. One thing to consider is if you really want the highest degree of accuracy possible on this map is to plan GCPs for this map on all the corners 50 feet inside the map plan to ensure we have enough photos. So on this map, I'd probably put one up here in this corner, one here, one here, one here, one here, and then possibly one in the center of my map. Generally for RTK-enabled drones, you really only need one for every 200 images. So we have 276 here, so we really only need, 1 to 2 GCPs on this project. But if I wanted a high degree of accuracy, I would want to capture the corners. So maybe I would do 4 or 5 just to capture the corners of this map and really ground and anchor those corners in to a real world coordinate. But I have decided that for this one, we're going to go with the single GCP workflow. So we'll see how it turns out.
All right, our first step on getting the site survey done with the ground control points and the checkpoints, we decided here to start on the edge of the site with a checkpoint. Now, a checkpoint is the exact same thing as a ground control point. It's still a point in the ground that you survey with your GNS station. You're going to record the coordinates and upload them to DroneDeploy. There's nothing that changed practically in these points between the checkpoints and these ones. It's just that the checkpoints are not used for processing, but we do need them to actually evaluate the accuracy of the site. To get the survey in using the Emblet, we need to connect the Emblet to an N-trip network and a hotspot. In this point, I'm using my device as a hotspot, and I have a connection subscription to a provider that is inputting the correction into the Emblet. Whenever you go and set up that connection, you have to get the credentials from your provider, and they're going to give you a passport and a username together with a port number. It's very important to have the correct port number for the area that you're surveying. Once you input that, the main screen that you have to look into the Emblet is going to be on the status. The status is going to tell you how many satellites you have in reach right now, and if you're receiving corrections or not. The most important thing before you record this is that you have a fix. A fix is not going to be achieved if you're too close to buildings or if you don't have a strong internet connection. Now that we have a fix, we can be confident that the coordinates that we're going to be recording now are going to be precise. So we place the rod on top of the target. The target is a high contrast checkerboard target. The most important thing in your targets is that we need to be able to see the center precisely as possible. You can spray paint it, but we suggest if you're going to go that route to actually use a stencil that actually is going to mark or delineate that center as precise as possible. As you can see in this one, this nice target does have in the center an opening. We're going to be placing the rod. You want to have it as level as possible. In this case, my rod does have a level in the side that I just need to make sure that is not leaning too far above the delineation of what is leveled. Now, to start surveying your points in Emblet is super easy. You just have to start a survey. You create a new survey, and here you're going to give it a name. Now, besides the name, the most important thing is going to be your coordinate system. Your coordinate system, the best way to define it is going to be identifying the EPSG code, and just make sure that you're surveying in a code that you're actually going to be flying and processing in DroneDeploy, but also if you're going to be using the data outside of DroneDeploy to have that same code on whatever design files projection system you're using. So it's very important to have a cohesiveness on the EPSG code throughout the life cycle of the capture. In this case, we're using a provider that is using WSG84, so I'm going to try to match their settings, even the vertical datum, to whatever they're using, because it's very important that this, considered the rubber, is matching whatever the base is projecting. And then once we have that defined, we are going to start surveying.
All right, so for this point, one of the considerations we had is that we wanted to make sure that when we're setting up these targets, they are 50 feet away from any obstacles, so trees, buildings, things that could obstruct the view from the drone to this target when we're actually doing our mapping mission. So here, we're about more than 50 feet away from any obstacle. We're in a clearing here, and we'll have a really good picture of this target from the sky when we do that mapping mission.
So we're getting ready to fly our Mavic 3 Enterprise. The very first thing that I do is to connect to a hotspot again, and that's because I'm going to be opening DroneDeploy and we want to get RTK signal. So I just connected it to the hotspot by swiping down, clicking into the Wi-Fi area. I'm looking for my hotspot. Right there is connected, so we got good signal. Coming back to DroneDeploy.
So for this flight, we're going to be flying with RTK instead of PPK. We do have good RTK connection on this site. So we're going to be using RTK as our default workflow here, which means we need to be connected to a mobile hotspot or internet connection on the controller to have that work in DroneDeploy. If we were using PPK, we would want to turn off that internet connection altogether and upload those MRK and OBS files, which we'll talk about later for flying with PPK versus RTK. RTK is going to be real-time kinematics, so we're going to be making corrections to these images from the drone in real time. So that's why we require a strong internet connection and RTK coverage at this site. Where PPK, you would want to fly that in sites with no coverage or limited coverage on our RTK network. Also, anywhere where you may not get like an internet connection on the controller. The key takeaway there is, you want at least 10 minutes for convergence time on PPK. We do advertise in fast regions, around 2 minutes, but I definitely suggest trying to get that flight time around 10 minutes for a PPK flight.
All right, as we're getting ready to start our flight, checking our altitude and everything, we're satisfied, airspace is good, RTK coverage is green. I can start my pre-flight checklist. Submit it. Here is a good idea, again, to check that RTK flag. If it's amber, it's still gonna give you an alarm, and you can retry that connection and then make sure that it gets to the green. Once that flag is green, you're good to go. You should be getting corrections for the flight. We're gonna click start flight and check our drone. It's very important for the RTK for your controller to remain connected to your hotspot. So just make sure that you don't disable the hotspot in your phone or a hotspot device that you might be using. If you do that during flight, you're for sure gonna be losing that correction signal during flight. Okay, after collecting all the data on the site, I am ready to upload the images. We're on the upload tab. I'm gonna click new upload. I'm gonna choose my files, which is going to be from my SD card. I'm gonna try to find the folder for the images that were captured on this location, which are going to be these ones. I'm gonna select all of them. If I do include these two files, that .mrk and .obs, I will also have a PPK correction on my map. As we can see in this next screen, we do have more options towards the right-hand side on my map. I'm gonna click into that, and I do have the option to add GCPs. I can download the right template over here, paste my coordinates that I got from the Mblit file, which I already did, and we are going to upload that CSV right here. It's going to identify the EPSG code. It's going to make sure that one is right, and I'm going to start uploading. And then my next step is going to be to wait for an email to review the ground control points. Okay, after the map processes in the cloud, you are going to get an email to review the ground control points. So we will click into that email, and then we're gonna get to this screen. On this screen, the main thing that we have to do is to make sure that the crosshairs are hitting the center. I'm gonna click on edit to actually have a closer look on each of these points. They seem to be pretty decent, but it's important to even fine tune it to make sure that we don't introduce any inches of error by not hitting the center. All of these look pretty decent, and I'm just going to be continuing to review each one of these. Some of them are just a little bit off, especially this one in the bottom. You might have more images, and over here in the top, if you have this button, it's good to click on it, and it's going to take us to another screen with more images that actually touch that point. If I am happy with the aim of all of these points, I can proceed and click on the top, submit ground control point, and move on to the next one. Since in my CSV, I already had labeled 2 of my points as checkpoints, they already appear here as checkpoints, but I still have the option by clicking into this window to change it to a ground control point or vice versa. Okay. After you're happy with all of your points, you can have a final review right here and then click submit. The map is going to process again, and it's going to get fixed to those points, and you're going to get an email with that map is ready.
All right, so now we're going to briefly talk about viewing our data after we've captured, we've uploaded, and we've processed our map. So the first thing we're going to go and check on is under map details. We're going to click on map and then go into processing report. And you can see right here that this is a new feature we're adding. We're showing you what high accuracy workflows were flown with this specific map. So here we have RTK, GCPs, and checkpoints applied to this map. Now that we're in the processing report, we're going to look at a few things first. So the average GPS trust here is super low. What this indicates to us is that we had a good RTK fix on our entire map. The higher the number is, the less trust or the less quality of an RTK connection we actually had on this flight. Anything less than 1 here is good number. This one specifically is 0.13 feet. This is what we want to see for our average GPS trust. The next thing you'll see here are the GCP and checkpoint count. We'll actually look at this in more detail further down the screen. The other thing to keep in mind here is our coverage quality. So this map right here is showing us that we had good overlap on our images. You can see some portions where we had a little bit more marginal coverage, where it's green here in the middle of the map. This makes sense on this specific map because we had tall trees that were captured in the photos. So the overlap on the difference in elevation between the ground and the top of the tree is going to be less at the top for overlap than at the bottom on the ground. I think that's going to be okay here. We haven't seen any issues to let us know that we have abnormal stitching or anything like that. And then finally, the tables that we're really concerned with here are our checkpoint values. So what we really want to see here are, anything less than 2 inches is really what we consider a good map for a high accuracy mission. Obviously, we would like to get these tolerances as tight as possible, so the less error here, the better. Generally, we will always see better results in the XY than the Z-axis, but overall, this looks like a pretty good map. Our Z error is less than 2 inches, and our XY is sub-inch accuracy here. Also, we don't see any issues with the tagging on this GCP, and no issues stand out in this report. So, single GCP workflow we flew on this site. It was a relatively small site, and we saw good results by placing 2 checkpoints throughout this map, one on the north side, one on the south side, and our data is good, and we can trust this for alignment, we can trust this for earthworks calculations, and we can trust this to pull these exports like point clouds, our OBJ file, any geotiffs into other software to rely on this data to align to any modeled objects or anything like that we have in other software. We can also rely on this data for pulling in georeference files to ensure that
those georeference files will align in DroneDeploy.